Let us discuss few concepts regarding Boolean algebra. So generally what happens is whenever you want to design any kind of system, okay, so let's say I'm designing a digital system which is having, let's say, 3 inputs and 2 outputs. So these are the 3 inputs and this is what the output is. So let's say the input terminals are A, B, C and the output terminals are Y1 and Y2. So generally what happens to it is in the digital system, the relation between input and output is very important. In any system, input-output relations is very important. So how to express or how to represent this system? So what we do is we write the input combination for all the 8 possible combinations. Let's say you have 3 inputs here and each of them can take value 0 or 1. So you can have 2 raised to power 3, 8 number of possible combination. If you have 10 number of inputs, you will have 2 raised to power 10 number of input combinations. So for in this case, so you have 3 inputs, so 2 raised to power 3 number of input combination. So for each input combination, you will be finding the outputs and you will be representing that in the form of a table. So maybe the table will look like this. So this is A, B, C, this is Y1 and this is Y2. So for 0, 0, 0, what is the output? Let's say 1, 0. For 0, 0, 1, what is the output? Let's say 1, 1. For 0, 1, 0, what is the output? Let's say 1, 1. Like this. So like this, you have to write the, for every input combination, you have to write the outputs. But imagine a case if the number of variables are more, then this table will look very bulky. There will be so many number of rows. You don't want that. So what we'll be doing is we'll be representing the same tabular information of truth table in the form of expression. And that expression is called the logic expression. The relationship between input and output in a digital system, we say it is logic expression. In what logic the output is changing with respect to the input. But okay, that is fine, students. But the problem is, let us imagine a case that suppose, for example, in any arbitrary system. So let's say y1, you are getting this as in this case. Let's say it is a bar bc plus bc plus abc and so on and so forth. So like this, you are getting the expression is. Now, whenever you want to implement this particular expression in the form of hardware. So in the digital system, the hardware are nothing but the logic gates, mostly the logic gates. So you have to implement these all things using the logic gates and various connecting wires. But whenever you are designing any system, your concern should be how to simplify the hardware complexity. So if you want to design this expression directly, maybe you need, let's say, 10 number of logic gates. So your effort should be how to reduce this 10 to a smaller number, might be 3 or 4 or even less than that. So what is the benefit of it? If you are reducing the hardware, it will be cost effective, power dissipation will be less, complexity will be less, and there will be so many advantages. So that is what the goal is. So we want to simplify a given logical expression. In this aspect, Boolean algebra comes into pictures. There are broadly 3 techniques actually. One is the Boolean algebra, students. One is the K-map and something known as the Queens-Mackley method or the tabular method. So Queens-Mackley method is not in the course. K-map we'll see. And now let us first see Boolean algebra. Okay. So there are certain advantage and disadvantage of Boolean algebra in its own place. Similarly with the K-map also. So let us see Boolean algebra. So what is Boolean algebra? Boolean algebra is a tool to minimize or to simplify the given logical expression. So we'll have some expression. For that, we want a simplified expression. So for that, we'll be using the Boolean algebra. So let us see some intro part of this Boolean algebra. So you see the first point I have written here that Boolean algebra is a basic tool to minimize various digital logic expressions. Any Boolean variable can take 2 possible values, that is 0 and 1. So like in normal algebra of maths, so let's say if I'm saying x is a variable, x can have infinite possibility, right? X can take any like infinite number of possible numbers. But here in the digital system, so any Boolean variable if I speak, so by default it will take only 2 values, 0 and 1. There is no even third possibility. Okay. So what is the benefit of this also? I'll show you after some time. Boolean algebra is based on 3 operators, namely not, and, or operator. Okay. So entire Boolean algebra is based on these 3 operators. We'll understand what is the utility of these all operators. And remember, students, in this algebra, we don't have anything else. We don't have subtraction. We don't have log. We don't have square. We don't have division. We don't have square root. Like n number of operation what we are studying in our normal algebra or mathematical algebra. So those are not applicable in case of Boolean algebra. So Boolean algebra is strictly based on not and or. For example, we'll see that suppose a equation is given a plus b is equals to b plus c. Okay. So then in this case, students, so if it is normal algebra in normal maths, so I know you will be cancelling b and b, you will be saying it is a equals to c. But you cannot do something like this. Why? Because when you are doing this b and b are cancelling, you are cancelling. So basically you are doing this subtraction operation. You are bringing this b to this side. So then b minus b becomes 0. So by subtraction you are cancelling this. But subtraction is not allowed in this case. Similarly, if you have, let's say, AB equals to AC, so you cannot say A and A are cancelled out, so then it is B equals to C. Because again, that division, multiplication, these all things are not applicable in case of Boolean algebra. So you should be very particular while dealing with these all expressions that you are not exceeding anything beyond this not and or. All right. So I'll show you what is the utility of these all applications of this. We'll see. First, let us have a look on this operator, not operator, and operator, and or operators. So while teaching the students, so I believe many of you have, like who have gone through basic electronics course or digital electronics course, or you have prepared GATE, up to certain extents. You must have some idea regarding these all. But while teaching you, I am assuming that to whom I am teaching, they don't know anything. So from this scratch level, I am teaching. But while taking the questions, so I'll make sure like whatever the concept I'm discussing in a questions, so there is no missing link between the concept and the questions. Okay, so that's why for a continuity, I'm covering each and every point so that while solving the questions, we don't have any missing link. All right. So a not operator, if you have a variable a, if you apply not operation on this, it become a bar. Or if you have a variable a bar, if you apply not on this, it is a. So not is meant for complementing a variable. If you apply a, you get a complement. If you apply it on a bar, you get it is a. This is the not operator. Next one is the and operator. So the first one says a variable added with itself is the same variable. A and a is a. Don't say that a dot a is a square. This is not the multiplication, please. Okay, it is not multiplication. In normal math, it would have been a square. So it is a added with a is a. A variable added with its complement is always 0, right? A variable added with its complement is always 0. So a variable added with 0 is always 0. So any variable, if you are doing and with 0, you get always 0. If you are doing and of any variable with 1, you get the same variable. A and 1 is a and 0 is 0, a and a bar is 0, a and a is a. So, like in a proper flow, okay, while we are in a flow, we say a into a is a into 0 is 0. It is not into, it is not multiplication. Strictly, it should be, you should pronounce it a and a bar, a and a, okay, or a dot a, like that you can say, but don't say into. Even if you say into, in your mind, you keep always that it is not the multiplication, please. So, okay, so these 4 things you should remember. We'll be using this to solve some questions. Now, a plus a equals to a plus a bar equals to 1, a plus 0 equal to a plus 1 equals to 1. So, a plus a is not 2a, please, it is a. So, any variable or with itself is the same variable. Any variable or with its complement is always 1. Any variable or with 0 is a. Any variable or with 1 is always 1. So, we'll be using this property repeatedly. We'll be using this property repeatedly. Okay. Very simple things, friends. You know this, but keep these things in mind that we'll always using this. Any variable or with 1 is always 1. Any variable and with 0 is always 0. So, based on this, let us solve one questions which is asked in one of the GATE papers. So, I think I have collected it here. So, this is the questions. Yes, this question, students. This question is asked in one of the computer science paper of 1995. The question is, what values of a, b, c, d satisfy the following simultaneous Boolean equations? So the equations are a bar plus ab equal to 0, ab equals to ac, ab plus ac bar plus cd equals to cd whole complement. So based on these 3 equations, we are supposed to find the value of abcd. So let me write the equation. So a bar plus ab equals to 0, ab equals to AC. Then you have AB plus AC bar plus CD equals to CD bar. So based on these three equations, you are supposed to find the value of ABCD. It looks something odd. Why it looks something odd is, like we have learned that the number of equation needed to solve the number of equation needed to solve a set of equation, it should be equals to at least the number of variables. In this case, we have four variables, namely A, B, C, and D, but we have three equations. So four variable and three equation, or three equation, we have four unknown. So if such could have been the case in the normal algebra and normal maths, then no solution exists, because we will say that we need at least four equations, but we have three equations. But let's see what is happening in case of the Boolean algebra. Okay. So in the Boolean algebra, what we'll be doing is, so here the first equation, if you observe, that A bar plus AB equal to 0. So from this, so you need the answer of OR is 0. So definitely this should be 0 plus 0, then it will be equal to 0. Because if any of the variable is 1, so what we have studied now, 1 plus A is equals to 1. So this A could be 0 or 1. We said any Boolean variable can take only two possible values, 0 or 1. So 1 or with any variable is always equals to 1. So if among these two, if any of this is 1, then it will be 1. It won't satisfy this 0 condition. So if you want this to be 0, indirectly I can say that this should be 0 and this should be 0. Because if this is 1, let's say, then 1 plus something is 1. It won't satisfy. Or if this is 1, let's say, then something plus 1 is 1. It won't satisfy. Or if you take both are 1 also, it is 1. So if you want this to be 0, so I mean that this term should be 0 and this term should be 0. So that 0 or with 0 is equals to 0. So because I am saying that A bar equal to 0, A bar equal to 0, it means that A equals to 1. Because if A equals to 1, then its complement will be 0. So I got A equals to 1. So you see all the four options are A equals to 1. Okay, so fine. Next thing is you need AB equals to 0. You need AB equal to 0. So if you need AB equal to 0, you already got the value of A. So 1 and with B equals to 0. So what is going to happen then? If you make B equals to 1, 1 dot 1 will be 1. So B is not 1, B should be 0. So B is 0. So 1 dot 0 equal to 0. So that means you got B equals to 0. So you got B equals to 0. So option B is gone. So B equals to 1 is not valid. So you got A, you got B. So now let us substitute here AB equals to AC. In this, let us substitute the value of A and B. So A is 1, B is 0 is equals to A is 1 dot C. So 0 equals to C. 1 dot 0 is 0, 1 dot C is C. So C equal to 0. So you got C equals to 0. So C equal to 0 means option C is eliminated. So this is not valid. So you got ABC value. Now let us substitute ABC value in this equation to get the value of D. A dot B 1 dot 0, A dot C bar 1 dot C bar, C is 0, C bar is 1, 1 dot 1 plus CD. C is 0, 0 dot D is equals to CD bar. C is how much? 0 dot D. Okay, so this is 0 plus 1 plus 0 is equals to, I think student there is a printing mistake. This is actually CD bar. 1 second. CD whole complement it is 0 AC bar. 1 second. 1 CD. Yeah, this is actually CD bar, students. I mean, this is, please make a change. So this is CD bar. So this is your C D bar, not C D bar, C bar D. C bar D. So if it is C bar D, I mean this is C bar D. So C is 0, C bar is 1 dot D. So D equals, so this is your D's. So D equals to 1. So D equals to 1. Please make a change to it. This is actually C bar D, not CD whole complement. So if you see this, so A equal to 0, B equal to 0, C equal to 0, and D equals to 1. So option A is the right answer. Right? So see, this is what happens in case of Boolean algebra. In normal algebra, we couldn't have solved this problem. So because in Boolean algebra, any variable can take only two possible values, 0 and 1. From a single equation itself, we got the two value. So from this equation itself, I got two value, which is not possible in normal algebra. So this is happening because these are the Boolean variable, not the normal variables, right? So now let us see, students, some properties of this Boolean algebra. You can say they are the properties or law or theorems or something like that. So in normal algebra, we study many different kind of law: commutative law, associative law, distributive law. So these things are equally applicable in case of Boolean algebra also. So let me just quickly revise it what it is. So first one is commutative property. Commutative property is defined in two flavors. One is with respect to AND operator, one is with respect to OR operators. So with respect to AND operator, it is A dot B equals to B dot A. So in what order you are doing the AND combination doesn't matter, or A plus B equals to B plus C. In what order you are doing the OR also, it doesn't matter. So A dot B equals to B dot A. Similarly, A plus B equals to B plus C. Next thing is associative property. So commutative property is defined with respect to two variable, students, but associative and distributive property, they are defined with respect to three variables. Again, in associative, we have two formats, one with respect to OR, one with respect to AND. So A plus B plus C is equals to A plus B plus C. You want to find the OR combination of three Boolean variable. So it doesn't matter which two you pick first. So either you can do A plus B resultant with C, or first you can do B plus C resultant with A. So A plus B plus C is equals to first A plus B then with C, or first B plus C then with A. Similarly, you want to have what is ABC, then it is equivalent to AB dot C or A dot BC. Distributive property says that A plus BC is equals to A plus B with A plus C, and A dot B plus C is equals to AB plus AC. Here one simple thing I'd like to highlight, student, is this one. See, so A plus BC equals to A plus B with A plus C. So how is it happening actually? So let me tell you, and I'll be deriving on shortcuts that shortcuts will be using to solve certain questions. So A plus B with A plus C, we want to show that it is A plus BC. How this is actually happening? So you do like so you can, in your mind, you can assume that AND is equivalent to multiplication or is equivalent to addition. In your mind, you can assume that, but you are dealing with the operator, Boolean operator. Okay. So in normal algebra, you would have done A into A, then you would have done plus A into C, then plus B into A, plus B into C. Like that you would have done. So here also let me do that way. So A dot A plus A dot C plus B dot A plus B dot C. So A dot A is A plus A dot C is AC. B dot A by commutative law is AB, and this is your BC. So from the first three, so I can take A common. If I take A as common, so you get 1 plus C plus AB, sorry, 1 plus C plus B, and then it is BC. So we have seen that 1 or with any variable is always equals to 1, right? So this term is always 1, so you get A plus BC. So that is what? A plus BC. A plus B added with A plus C is A plus BC. So what is the shortcut that we can notice from this simple relation is, whenever you are finding the AND combination of two terms, whenever you are finding the AND combination of two terms, this is one term and this is one term. So in these terms, if the first variable are same, like here this is A and here this is A, then the resultant answer will be AND combination of the first variable plus AND combination of the second variables. So here in these two terms, the first variable are same. This is A and this is A. So the answer would be AND of A and A. A and A is A plus AND of second variables. AND of second variables AND of B and C. So A plus BC. So I'll be showing you how beneficial this relation is to solve certain questions. Okay, students. So let me show you how to make use of this in certain cases. So for that, so let me solve these questions. Okay. So this one let us solve. So if you observe, so these two questions I want to solve now. So let me take a fresh page, and the question is obtain the simplified expression of this. So let me take it. Okay. So in the first case, a plus b added with a plus b bar, then it is a bar plus b, then it is a bar plus b bar. So this one I can write as a plus b with a plus b bar. Let me put a bracket here. Similarly, a bar plus b and a bar plus b bar. Let me put a bracket here. So here you have AND combination of two terms. So the answer will be AND combination of, and that to be here you see a and a, these are same, first variable are same. So you can write the answer as AND combination of first variable plus AND combination of second variables. So when you are writing the AND combination of first variable is a dot a is a plus b dot b bar is 0. Or if I want to write in a very detailed way, so you can write a dot a plus b dot b bar, right? This is the first bracket. Second bracket, if you see, again the first variable is same here. First variable is a bar, here also it is a bar. So it is a bar dot a bar plus b dot b bar. So a dot a is a, b dot b bar is 0, and a bar dot a bar is a bar plus dot b bar is 0. So it is a dot a bar, the answer is 0, right? So any variable or with 0 is a, so that's why it is a, this is a bar. And a dot a is a, we have already seen, and a variable complemented to itself is 0, we have seen. So using this property, we are getting answer 0. So see student, because I am explaining, I am taking these many steps. Otherwise, so directly from this itself, directly you can tell the answer is 0. So, like using these shortcut techniques, some intermediate steps, what we would have done without knowing this property, we would have continued, but using this very shortly, we are getting the answer. So let us simplify this question. So here, let me put a bracket here and here. You can have your own way to solve it. And here you see students, so I can assume the first variable is a plus b, which is same in both of the term. And second variable is c and c bar. So the answer would be, for this bracket, the AND combination of first variable, which is a plus b ANDed with a plus b. We have seen that a ANDed with a is a. Any variable ANDed with itself is always a. So a plus b ANDed with a plus b is a plus b. Okay. Plus AND combination of second variable, c dot c bar. Okay. So this is what the bracket is. And then you have a plus b bar plus c. So now it is a plus b, and your c bar is 0. So it is a plus b, and this is a plus b bar plus c. So now the answer would be, again you see the first variable are same. First variable is a and a, second variable is b, and this is b bar plus c. So the answer would be AND combination of first variable, that is a dot a, plus AND combination of second variable, b dot b bar plus c. A dot a is a plus b dot b bar is 0 plus bc. So the answer what you get is a plus bc. So this answer is 0 and this answer is a plus bc. So see, so such kind of complex expression which could have taken around 6 to 7 steps, so we are able to solve in just 1 or 2 steps. So these are some steps I am taking just to explain you. Otherwise, you can do these all calculations in your mind. So just in 1 or 2 steps, we are able to reach the answer a plus bc. I hope this is clear, students. So let us continue with some more property of Boolean algebra like De Morgan's law and some other stuff in the next video.